Welcome back to The Explainer. So, today we're actually digging into a really fascinating piece of 8th grade educational material. We're going to unlock one of the absolute fundamental secrets of the physical universe, and that is Newton's second law. Basically, it's all about figuring out exactly why things move the way they do, and how engineers and even athletes use that exact knowledge to do some truly incredible things. But, before we really get into the hardcore physics, this curriculum actually anchors the whole lesson right up front with a really powerful quote from Colossians 3:23. It says, "Whatever you do, work at it with all your heart as working for the Lord." And honestly, the source material draws a pretty beautiful parallel here. See, in physics, force is just the effort or the push you apply, right? And acceleration is the movement that results from that push. So the lesson here is that, just like in physics, when you apply your heart and your full effort, you literally create real, tangible movement toward your goals. Okay, let's dive into this and look at the roadmap for today. First up, we've got the dynamics of force. Second, we'll be breaking down the formula. Third, it's the law in action. Number 4 is a quick homework and review segment. And then finally, we'll wrap up with education and morality. All right, section 1, the dynamics of force, why it matters. So why does this law actually matter to us in the real world? Well, the material positions this principle as literally the ultimate tool for engineers and athletes who want to push the absolute boundaries of what's physically possible. Once you master this law, you can build much safer bridges. It's the exact same secret behind building lightning-fast race cars, or even sending massive spacecraft all the way to the moon or Mars. No joke. And it's not just engineering. Athletes use this exact same principle every single day to completely maximize their power and dominate their sports. Section 2, breaking down the formula, force and mass. Now, the source positions this as the golden rule of motion. It's Newton's second law, which connects force, mass, and acceleration through one simple, incredibly elegant formula, F equals ma. That is, force equals mass times acceleration. So what does this actually mean in plain English? Well, it means that when you push or pull something, the amount of acceleration, how fast it speeds up, depends entirely on just two things. First, how heavy the object is, which is its mass, and second, how hard you push it, which is the force. If you change either of those factors, you completely change the movement. And this brilliantly illustrates the concept. Let's imagine you've got a baseball bat in your hands, okay? You swing it with all your might and you hit a standard baseball. Now, because that baseball has very low mass, your force causes really high acceleration. It flies right out of the park. But now, imagine taking that exact same bat, swinging with the exact same force, but this time, you hit a heavy bowling ball. Ouch, right? That bowling ball has high mass, so it experiences very low acceleration. It barely even moves. It's the exact same force, just a different mass, which gives you an entirely different result. And we see this F equals ma formula perfectly applied when it comes to high-performance vehicles. Think about it. If you want maximum acceleration on a racetrack, what do you really need? Well, you need a massive amount of force, right? And that comes from incredibly powerful engines. But you also need the lowest possible mass. That's exactly why engineers design these incredibly lightweight frames for race cars. Big force plus small mass equals maximum acceleration. It is literally pure physics at 200 miles per hour. Moving on to section 3, the law in action, real-world examples. Let's move to and see how this builds from just everyday stuff all the way to the extraordinary. Example 1, picture yourself pushing a grocery cart. An empty cart? Super easy to push. But as you toss in more and more groceries, the mass goes up. Suddenly, you have to apply way more force just to get it moving down the cereal aisle. Example 2, watch a sprinter at the starting blocks. The greater the force they can generate with their leg muscles pushing against those blocks, the faster their initial acceleration down the track. And finally, example 3, a literal rocket launch. To accelerate a gigantic spacecraft into Earth's orbit, it requires the absolutely massive force generated by rocket engines. The law applies exactly the same way whether we're talking about a box of cereal or a spaceship. All right, section 4, homework and review. Let's test your knowledge. So the curriculum goes into this rapid-fire pop quiz mode to help visualize the law. Question 1. How do you write it as a formula and in words? Get it in your head. The answer, of course, relies on those 3 famous letters. F equals ma. Force equals mass times acceleration. Okay, question 2. If the mass of an object stays exactly the same, how does applying more force affect its acceleration? Think about it. If you push the exact same object much harder, the acceleration increases. Let's flip it for question 3. If your pushing force stays the exact same, but the object suddenly gains a whole lot more mass, how does that affect the acceleration? Just remember that bowling ball example. More mass means less acceleration. The object slows down. Question 4 asks for an example of the second law in sports. Try to picture it. You could use the baseball flying off the bat because of its low mass, or maybe that sprinter using powerful leg force to explode off the starting line. And lastly, question 5. Why are race cars intentionally designed to be lightweight? So, the crucial point is that lowering the mass while keeping a powerful engine's force incredibly high is the ultimate recipe for achieving the absolute highest acceleration possible on the track. Finally, Section 5, Education and Morality, the Godly Learners Series. At this stage, the HeroSmart Academy material does something really interesting. It intentionally intertwines biblical morality directly with the science education. The text makes a really serious point here. It argues that education without morality will ultimately hurt. Being highly educated is great, but it's kind of pointless if you're making poor moral choices that cause pain to yourself or the people around you. Scientific intelligence has to be paired with a strong moral compass to build a truly successful life. The curriculum leaves us with a final, really comforting thought from Romans chapter 8, verses 6 and 7. The mind governed by the Spirit is life and peace. The source uses this to promise a profound peace of mind to anyone who combines their hard-earned education with a real spiritual foundation. It's a genuinely thought-provoking approach to science education. It really prompts us to ask, regardless of our backgrounds, once we actually understand the forces that move the universe, how will we use our own force to accelerate goodness in the world today? Thanks so much for joining me, and I'll catch you in the next explainer.